Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in the last class we were discussing the chapter Polynomials, right? Now let's go for continuing this, and do remember this is fourth period of this chapter. And yesterday we learned the concept, that is the relationship between zeros and coefficients of a polynomial, right? In that it may be the linear polynomial, quadratic or cubic polynomial. Regarding linear polynomial, you know that it has only one zero, that is alpha. And the relationship between zeros and coefficient is alpha equal to minus b by a. Then could you tell the polynomial, general form of the polynomial when its zero is known? Yes, it is p of x equal to x minus alpha, right? And second one, quadratic polynomial. It has two zeros, they are alpha and beta. What is the relationship between zeros and coefficients? It is alpha plus beta, that is sum of zeros, is equal to minus b by a. And the product of zeros, alpha into beta, equal to c by a. Then what is the general form of quadratic polynomial when its zeros are known? It can be written as p of x is equal to x square minus of alpha plus beta into x plus alpha beta. Got it? Yes. Third one, this is cubic polynomial and it has three zeros. They are alpha, beta and gamma. Then the relationship between zeros and coefficients can be written as alpha plus beta plus gamma, that is sum of zeros is equal to minus b by a. Then alpha beta plus beta gamma plus gamma alpha, it is nothing but the sum of the product of two zeros taken together. It is c by a. Then alpha into beta into gamma is equal to minus dA. This is the product of zeros, right? And even we have come to know the general form of cubic polynomial when its zeros are known. That is p of x is equal to x cube minus of alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma, right? So based on this, even we solved some of the problems. Particularly we focused more on quadratic polynomials, right? When a quadratic polynomial is given, we learned how to find out the zeros of the quadratic polynomial, and also we verified the relationship between zeros and coefficients. I had given you two problems as homework, right? I hope that you might have finished. Just I go for writing them, you go for checking that answer. The question was, it is 4s square minus 4s plus 1. This was the quadratic polynomial. We had to find out its zeros. First, you will go for equating 4s square minus 4s plus 1 to 0, right? Then, by splitting the middle term, you go for factorizing this. First and last term, here 4 and 1. 4 ones are 4. And the middle term is minus 4. And the factors are 2 and 2. See that 2 2s are 4. 2 plus 2, 4. But we want minus 4. So I take minus 2, minus 2. Minus 2, minus 2, minus 4. Minus 2 into minus 2 is plus 4. Now we can write this statement as 4s square minus 2s minus 2s plus 1 equal to 0. Let us go for grouping by taking two factors. Here 2s is common factor. The remaining 2s minus 1. Here no term is common factor except 1. Hence I go for taking 1 as common factor. Then this is 2s minus 1. It is equal to 0. In the whole statement, 2s minus 1 is common factor, remaining 2s minus 1 equal to 0. Then equate 2s minus 1 to 0 and second term 2s minus 1 to 0. Let's go for solving. Yes, 2s equal to 1. Then s equal to 1 by 2 by transposing 2 to the denominator of RHS. Next, another one, again 2s equal to 1, s equal to 1 by 2. So therefore 1 by 2 and 1 by 2 both are the zeros of the given quadratic polynomial. Here I'll write, therefore the zeros are 1 by 2 and 1 by 2. Next, we had to verify the relationship between zeros and coefficients. For verification, I go for assuming the first zero as alpha, that is alpha equal to 1 by 2, and second zero beta, that is also equal to 1 by 2. Then the coefficients, observe it is in standard form. Go for writing the values of A, B and C. A is 4, B is minus 4 and C is 1. Next, for verification, you may go for taking any one of the two statements. One is alpha plus beta equal to minus B by A, or second one alpha into beta equal to C by A. Any one of these two can be verified. Here I'll write LHS alpha plus beta, that is sum of zeros, where alpha is 1 by 2, beta is 1 by 2. Okay, directly you can go for writing half plus half 1. Then RHS, it is minus B by A minus of, where B is minus 4 and A is 4. 4 get cancelled, minus into minus plus, that is also 1. LHS equal to RHS because both are equal to 1. Hence you can write alpha plus beta, it is equal to minus B by A. That is, the relationship between zeros and coefficients is verified. Right? You just go for checking the answer, what you have written. And even we have taken one more. Now I'll go for writing it. Another homework problem was, it is 3x square minus x minus 4. I'm going to write it. So you just go for checking it. It was 3x square minus x minus 4. It is in standard form. First, you are going to find out the zeros of this polynomial. So 3x square minus x minus 4 should be equated to 0. Multiply first and last term. It is minus 12. 3 into minus 4, it is minus 12. Middle term is minus 1. Then what are the factors? See that 4 and 3. 4 3s are 12. 4 plus 3, 7. But we want minus 1. If you take 4 minus 3, it will be 1. But we want minus 4 plus 3 is minus 1. Minus 4 into 3 is minus 12. Now 3x square minus 1 can be written as minus 4 plus 3. So minus 4x plus 3x. Constant minus 4 as it is. You may go for taking common factor. Here, what is the common factor? Only x. It is, when you take out x as common factor, you will get 3x here minus 4. X into 3x, 3x square, x into minus 4, minus 4x. Here also, there is no common factor except 1. So 1 into 3x minus 4, which is equal to 0. Then, in the whole statement, 3x minus 4 is common factor, remaining x plus 1 equal to 0. Equate 3x minus 4 to 0 or x plus 1 to 0. Then here 3x equal to 4, x equal to 4 by 3. Hope that you have got the same. Then this is x equal to minus 1. Now therefore we can write the zeros are, what are the zeros? 4 by 3 and minus 1. We have to verify the relationship between zeros and coefficient. Then zeros are, it is 4 by 3 and minus 1. Let alpha equal to 4 by 3 and beta equal to minus 1. Then I'll go for verifying either alpha plus beta equal to minus b by a or alpha into beta equal to c by a. I'll take this time alpha into beta. What is alpha? 4 by 3. Beta, it is minus 1. It is equal to minus 4 by 3. Then RHS, it is c by a. What is c? Here we have to write a, b and c values. A is, here I'll write. A is 3, b is minus 1 and c is minus 4. It is equal to c. C is minus 4. A is 3. This is also minus 4 by 3. So, by comparing LHS and RHS, we can write LHS equal to RHS. Hence, alpha into beta equal to C by A is verified. Right? Okay. Now, we will move on to the next problem. In the next problem, this time we are going to take the problem related to cubic polynomial. Some numbers are given. You are going to check whether these numbers are zeros of the cubic polynomial. Let me go for writing the given question. Now observe. Fourth one. See, verify that 3 minus 1 and minus 1 by 3 are the zeros of the cubic polynomial 3x cube minus 5x square minus 11x minus 3. Then and verify the relationship between the zeros and coefficients. Now you tell that how you are going to check whether these are the zeros of the given cubic polynomial or not. Very simple. Here the cubic polynomial is in x. You have to substitute these numbers one after the other in place of x. After substitution, if you get the value of the cubic polynomial as 0, then you can say these numbers are zeros. Right? Now, first let me go for verifying. Here I write verification. In verification, they have given the polynomial, cubic polynomial. This is 3x raised to the power 3 or 3x cube minus 5x square minus 11x minus 3. Now, let us take 3 in place of x. It is p of 3. It is equal to 3 into, in place of x, 3 whole square, 5 into 3, sorry, this is cube, whole square, minus 11 into 3 minus 3. It is equal to, what is 3 cube? 3 cube, 3 into 3 into 3. 3 3s are 9, 9 3s are 27. 27 3s are 81 minus. What about the value of 3 square? 9. 9 5s are 45. Now 11 3s are 33 minus 3. 81 minus 45 minus 33 minus 3. Just observe 40 and 30, 70, 78, 78 minus 78 minus 3 minus 81. Both get cancelled, 0. So P of 3 equal to 0. The value of the cubic polynomial is 0 when x is 3. Then what do you say about 3? It is called the 0 of the given polynomial. Here I write, therefore 3 is the 0 of P of x. Similarly, I go for verifying for other two numbers. The other two numbers are, look here, minus 1 is there. It is P of minus 1. P of minus 1, which is equal to, now you are going to substitute minus 1 in place of x. Here 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into, what is it? What should be written in place of x? It is minus 1. Minus 1. It is equal to, what is minus 1 whole cube? It is minus 1 only. Okay. Minus 1 into minus 1 into minus 1. Here minus into minus plus, plus into minus, minus. So 1 1s are 1, 1 1s are 1. It is minus 1. Minus 1 into 3, minus 3. If the power is odd, we'll get the same sign. If power is even, the value becomes positive. Now, minus 1 whole square. See that power is even. Minus 1 whole square is 1. 1 into minus 5, minus 5. Now here, minus into minus, plus 11 ones are 11. Then minus 3. It is equal to minus 3, minus 5, minus 3. Minus 8, minus 3, minus 11, plus 11. Both get cancelled. 0. So P of minus 1 is equal to 0. Clear? Now, here the value of the given polynomial is 0 when x is minus 1. Then what do you call minus 1? This is also a 0 of the polynomial. Here I'll write. Therefore, minus 1 is the 0 of P of x. Next, we have one more number, that is minus 1 by 3. Let us check whether it is 0 or not. Here, P of minus 1 by 3, it is equal to 3 into x cube. X is minus 1 by 3 whole cube. Minus 5 into x square, minus 1 by 3 whole square. Minus 11 into minus 1 by 3. Then minus 3. It is equal to, now observe here, 3 into, what is minus 1 whole cube? Here, cube should be applicable to both numerator and denominator. Minus 1 whole cube is minus 1. 3 cube. 3 cube is, it is 27. Because 3 3s are 9, 9 3s are 27. Next, here minus 5 as it is. Apply square to both numerator and denominator. Minus 1 whole square is 1. 3 whole square is 9. Minus, here observe, minus into minus, plus 11 ones are 11. 11 by 3, minus 3. This is equal to, here we have a chance of cancellation. Observe, 1s are, 9s are. Hence now I can write it as minus 1 by 9. This is minus 5 by 9. This is 11 by 3 and is minus 3. Now, let's go for taking the LCM. What is the LCM? LCM of all the denominators is 9. Multiply LCM with first term. Get cancelled, minus 1. Multiply LCM 9 with second term. 9 9 get cancelled, minus 5. Multiply 9 with third term. 3 1s are, 3 3s are, 11 3s are 33. Then multiply LCM with fourth term. 3 9s are 27, minus 27. Observe here. You can come to know that minus 1 minus 5, minus 6. Minus 6 minus 27, it is minus 33. Then plus 33 whole divided by 9. Minus 33 plus 33 is 0. 0 by 9 is 0. Because we all know that 0 by anything is 0. Now here I'll write P of minus 1 by 3 equal to 0. The value of the given cubic polynomial is 0 when x is minus 1 by 3. Followed? Then what do you say about minus 1 by 3? That is the 0 of the polynomial. Here I'll write. Therefore, minus 1 by 3 is the 0 of given polynomial. Got it? First one we verified and we have come to know that all the three given numbers are zeros of cubic polynomial. Next, what is the second sub question? It is, again you have to go for verifying that. What you are going to verify? The relationship between the zeros and coefficients. Yes, I don't have space here. Now, I'll write that there. Before that, you please copy from there to here. Yes. Now, let's go for verifying. First, I'll go for taking the zeros. What are the zeros? Zeros are alpha equal to, first one was, it is 3. Second one, minus 1. And third one, I take this as gamma. It is minus 1 by 2. These are the zeros. Now let's go for writing the coefficients. Here I have written the given polynomial. Let us write the coefficient. A. What is A? It is 3. B. The coefficient of x square. It is minus 5. C. It is minus 11. And D is minus 3. Now, we have to verify the relationship between zeros and coefficients. With respect to cubic polynomial, we know the three statements. You can go for verifying any of these three statements. Yes, I go for taking the first one, that is sum of zeros. Alpha plus beta plus gamma is equal to, what is alpha? 3. Beta minus 1. Gamma minus 1 by 3. What is the LCM? Before that, we can go for taking 3 minus 1, 2. 2 minus 1 by 3. Take LCM. It is 3. And multiply LCM with the first term, 6. With second term, 1. This is 5 by 3. Got it? It is alpha plus beta plus gamma. Then what is RHS? It is minus B by A. Right? It is equal to minus of, what is B? B is minus 5. A is 3. Minus into minus plus. So 5 by 3. LHS equal to RHS, hence it is verified. Here I write LHS equal to RHS, hence it is verified. Clear? Even you may go for verifying other two statements also. What are those? Second one is the sum of the product of two zeros taken together. You may just recall that LHS equal to alpha beta plus beta gamma plus gamma alpha. That's equal to C by A, right? Let us check it out. Alpha is 3 and beta minus 1 plus beta again minus 1. Gamma is minus 1 by 3. Next, gamma alpha. Gamma is minus 1 by 3 and alpha is 3. Got it? Now 3 and 3 get cancelled. Let's go for simplifying it. It is 3 into minus 1, minus 3. Minus into minus, plus. 1 ones are 1, 1 by 3. Then this is minus 1. It is equal to minus, say, 1 by 3, minus 3 minus 1, minus 4. Take LCM. LCM is 3. Multiply LCM with both the terms. Here 3 get cancelled, 1. 3 4s are 12. It is minus 11 by 3. This is LHS. What about RHS? Alpha beta plus beta gamma plus gamma alpha is, it is C by A. What is C? Observe, minus 11. A, it is 3. LHS is minus 11 by 3. RHS is also minus 11 by 3. We can write LHS equal to RHS, hence it is verified. Clear? Okay. Next, one more statement is there. The product of zeros, that is equal to minus D by A. You can verify that also. Here I'll write LHS, product of zeros, it is alpha into beta into gamma. What is alpha? It is 3. Beta minus 1 and gamma minus 1 by 3. 3 and 3 get cancelled. Minus 1 into minus 1 plus 1. And RHS, it is minus D by A. Minus into where D is. D is minus 3. A is, it is 3. Now, minus into minus plus, 3 by 3, it is 1. LHS is 1, RHS is 1. Therefore, LHS equal to RHS. Hence, you can also say that the relationship between zeros and coefficients, that is alpha into beta into gamma equal to minus d by a, is verified. You can write, hence it is verified. Got it? Hope that you have understood. Now it is a time to move on to the exercise number 2.2. So let's go for solving them. Please copy from there to here. Observe. Here we have questions from exercise 2.2. In that first one, see that in first question, find the zeros of the following polynomials and verify the relationship between the zeros and coefficients. Look here, these are the quadratic polynomials they have given. We have to find out the zeros of these and we should verify the relationship between zeros and coefficients. Dear students, whatever I have written, all these six, all are solved in yesterday's class only. And even I have given two problems for homework. This is 4x square minus 4s plus 1, 3x square minus x minus 4. These two are solved today. So from first May, we have given answer for all the questions. Okay. Now, come to second one. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. Here they are given two numbers and those numbers represent the sum of the zeros and product of the zeros, and you are going to find out the quadratic polynomial. And in worked examples only we have solved these three. That is first one 1 by 4 minus 1, and fifth one in this way minus 1 by 4 and 1 by 4, and sixth one 4 and 1. When these are sum and products, we have come to know how to form a quadratic polynomial. Now second one was not solved. Now I am going to take this one. Observe. Don't go for copying. Here root 2 and 1 by 3. Could you tell what does root 2 indicate? It is sum of zeros. 1 by 3, the product of zeros. So here I will write, let alpha and beta be the zeros. Why I have taken only alpha and beta? Because a quadratic polynomial has two zeros. One is alpha and second one is beta. Then here root 2, sum of zeros, nothing but alpha plus beta. It is equal to root 2. And 1 by 3, it is the product of zeros, alpha into beta, equal to 1 by 3. Dear students, you know that the quadratic polynomial can be written as, the quadratic polynomial when zeros are given can be written as p of x equal to x square minus of sum of zeros, that is alpha plus beta, into x plus the product of zeros, it is alpha into beta. Now this is equal to x square minus, what is alpha plus beta? It is root 2 into x plus alpha into beta, it is 1 by 3. So denominator, we have a term, so that you have to multiply that denominator with all the terms. If more than one denominators are there, you have to take LCM. But here there is only one, that is 3. Multiply 3 with all the terms. It becomes 3x square minus 3 into root 2 x plus 1. In bracket you can write 3 is multiplied. Got it? Therefore, the required quadratic polynomial is, or the quadratic polynomial is 3x square minus 3 into root 2x plus 1. Followed? Now, I go for taking one more. It is third one. Third one is 0 and root 5. It is also very simple. Directly you can go for writing. The zeros are alpha and beta, where 0 indicate sum of zeros, nothing but alpha plus beta, it is 0. And root 5 is the product, alpha into beta. Then again we have to write, we know that the quadratic polynomial, that is p of x is equal to x square minus of alpha plus beta into x plus alpha beta. Now it is equal to x square minus, what is alpha plus beta? 0. 0 into x. Alpha into beta, root 5. 0 into anything is 0. Hence x square plus root 5. So this is the required quadratic polynomial. Here already. Therefore, the quadratic polynomial is x square plus root 5. Clear? Yes. Please go for copying from there to here. Copy. Observe. One more is there in this way. That is 1 and 1. Here 1 is the sum of the zeros and 1 is product of zeros. Here I have written that. Let alpha plus beta equal to 1 and even alpha into beta is also same, that is 1. We all know that writing the quadratic polynomial when its zeros are given, it is p of x equal to x square minus of alpha plus beta into x plus alpha beta. Now x square minus, what is alpha plus beta? It is 1 into x. Alpha into beta, that is also 1. Now x square, 1 into x is 1x. Then 1 is written as it is. Therefore, the required quadratic polynomial is x square minus x plus 1. Understood? Dear students, the exercise 2.2 has been completed. Now, we have some interesting problems are there with respect to this exercise, and I have taken those questions from your reference books like Eschan, R.D. Sharma, OS1 and previous year question papers. So now let us go for solving them. Okay. Now you have to copy. I think you might have copied up to here. You take one more. Copy this. Dear students, let's move on to some of the important additional problems. In that I have taken first one. Just go through this. If alpha and beta are the zeros of the polynomial ax square plus bx plus c, then find the values of these 1 by alpha plus 1 by beta and the rest of this value. Here, have they given the numbers? No. Then how you are going to find out the value? Means we have to simplify these. I'll go for taking the first one. Observe this. It has been given that 1 by alpha plus 1 by beta. How do you go for finding the value of this? Do you know the value of alpha and beta? No. If both are known, we would have substituted, then it would have been easier to find out the values. But how to find out? Just by taking the quadratic polynomial ax square plus bx plus c. When you simplify this, then only will come to. Observe this. 1 by alpha plus 1 by beta is here. How do you simplify this? Yes. Can we go for taking LCM? You are right. Here, these two are different terms. Their product will be LCM. Then, multiply xm with both each term. When you multiply here, alpha get cancelled. Beta will remain. Beta ones are beta. Plus, multiply LCM here. Beta get cancelled. Alpha will remain. Alpha into 1, alpha. And the very simple thing is, when two different terms are there, their product is LCM. And remain, to write the numerator terms, you can just go for cross multiplication. Beta into 1, beta. Alpha into 1, alpha. It is nothing but alpha plus beta. Got it? Then what is the further step? Look here. We are very familiar with alpha plus beta and alpha into beta, right? How? Because we know that numerator term indicates sum of zeros. It is. Denominator is product of zeros. Both are known. How? When, if the quadratic polynomial is ax square plus bx plus c, then we can write alpha plus beta is equal to minus b by a. Is it not? Next, alpha into beta equal to c by a. Clear? Now we are going to substitute them here. What is alpha plus beta? Minus b by a. Alpha into beta, it is c by a. Now see that a and a get cancelled. It is equal to minus b by c. Therefore, 1 by alpha plus 1 by beta, it is minus b by c. Is it not simple? And also, is it not interesting? Okay. Both. Now, let us go for answering second. In the examination, there is a chance of giving it for 1 mark. Got it? So, do remember, if it is so, then the value of 1 by alpha plus 1 by beta is dash. Even there is a chance of giving this question in MCQ. Options will be given. And minus b by c, this will be the right option. Next, second one. Look here. Alpha square plus beta square is there. How do you go for finding alpha square plus beta square? We do not know both the values. But do remember, alpha square plus beta square, these two are in the form of an identity. Or these two are the terms of an identity. What is that? If you go for taking, look here. If you go for taking a plus b whole square, how do you write? A square plus b square plus 2a. Okay. Assume that a is alpha, b is beta. Then alpha square plus beta square. How do you write? A plus b whole square, transfer here, minus 2a. This is equal to a square plus b square. Did you understand? Now, alpha square plus beta square is there. Can we write alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta? Is it not? Okay. Now, let me go for taking substitution. Already we know what is alpha plus beta and alpha into beta. Both are written here. Where alpha plus beta is minus b by a whole square. 2 into alpha into beta is, this is c by a. Now, apply square to both. It is minus b whole square is plus b square. A whole square, it is a square. Minus 2c by a. Now, you can go for taking LCM of the denominator. What is the LCM? It is a square, right? Multiply a square with first term. Both get cancelled. B square will remain. Minus. Then, multiply a square with second term. Here, a get cancelled. A will remain. So, a into 2c. It is nothing but 2ac. So, therefore, alpha square plus beta square is b square minus 2ac whole divided by a square. Followed? Now, let's move on to third one. What is third one? It is alpha cube plus beta cube. Directly it is in the form of a particular identity. Can you tell that? Yes, recall it. It is in the form a cube plus b cube. Expand it. It can be written as a plus b into a square plus b square minus ab. Right? Here alright. Alpha cube plus beta cube can be written as alpha plus beta into alpha square plus beta square minus ab. Alpha into beta. Followed? Now this is equal to, we know alpha plus beta, that is minus b by a. Alpha square plus beta square, just we have found out. But assume that, imagine in the test only this question has been given. Is it possible to take substitution for alpha square plus beta square directly? No. Then it should be simplified. How? I'll tell you that. Alpha plus beta, keep that as it is. We all know that how to write alpha square plus beta square. It is nothing but alpha plus beta whole square minus 2 alpha beta. Clear? Next, minus alpha beta. Now this is equal to alpha plus beta as it is, or else I'll go for taking substitution directly because it will be easier. What is alpha plus beta? It is minus b by a into alpha plus beta whole square minus b by a whole square. Observe it. What is minus 2 alpha beta minus 1 alpha beta? It is minus 3 alpha beta. So 3 into alpha beta. Alpha beta it is c by a. This is equal to minus b by a into minus b by a whole square. It is b square by a square minus this is 3c by a. Understood? Now this is equal to, I'll write minus b by a as it is. Let's go for taking LCM. It is LCM is a square. Multiply LCM with the first term, get cancelled, b square. With the second term, a get cancelled, a will remain 3c into a, 3ac. Got it? Now this can be written as, you can go for multiplying this, minus b into b, minus b cube, minus into minus, plus b into 3ac, 3abc, by a into a square, it is a cube. So this is the value of alpha cube plus beta cube. Followed? So this is one type of problem, and one more is there, alpha minus beta. I'll go for finding the value of even alpha minus beta also. You just go for copying from there to here. Let's move on to fourth, alpha minus beta. Yes, how do you go for finding the value of alpha minus beta? If alpha and beta are the zeros of a square, ax square plus bx plus c. Yes, students, alpha minus beta, this is also a term in one of the identity. What is that? It is a minus b whole square, right? Okay. Here, a minus b whole square, that is nothing but a square plus b square minus 2ab. But we want a minus b only. A minus b is equal to square root of this. Understood? Yes. Here alright. Alpha minus beta whole square, this is equal to alpha square plus beta square minus 2 into alpha beta. And alpha square plus beta square, it should be expanded. How? Alpha plus beta whole square minus 2 alpha beta. Please do remember, this much is related to only alpha square plus beta square. Now remaining minus 2 alpha beta. Hope you have understood. In second problem only we have come to know that one. Now this is equal to alpha plus beta whole square. What is minus 2 alpha beta minus 2 alpha beta? Minus 4 alpha beta. Now it is, what is alpha plus beta? This is minus b by whole square minus 4 into alpha into beta. This is c by a. It is equal to minus b whole square, it is b square. A whole square, it is a square minus 4 into c by a. Now you take the LCM. LCM is a square into a square and a. Their LCM is a square. Multiply with the first term, get cancelled, b square minus multiply with second term, a get cancelled, a will remain a into 4c, 4ac. This is the value of alpha minus beta whole square. But what is actually needed? We want only alpha minus beta. Hence, I can rewrite this whole statement as alpha minus beta, this is equal to square root of b square minus 4ac whole divided by a square. This is equal to a square, it is a perfect square. So you can remove this from root, right? It is square root of b square minus 4ac as it is square root of a square. Square and root get cancelled, hence we can write it directly. So this is the value of alpha minus beta. Hope that you have understood. Dear students, just only for the sake of practicing, I'll give you few more. Just observe here. It is, you have to find out the value of 1 by alpha square plus 1 by beta square. And second one is, it is alpha by beta plus beta by alpha. And third one, you can go for square root of alpha by beta plus square root of beta by alpha. It is just for practicing only. You can continue the numbers. Total 4 are over. This is fifth one and is sixth one. You can take this as seventh one. Okay? Yes. This is one type of problem. Very important. Now we will move on to another interesting type of problem. And before that, pause the video and copy from there to here. After that, you just continue this. Try to find out the values of these. Yes, copy. Dear students, I told you another interesting problem. This is second one, which resembles previous one. How? Look here. If alpha and beta are the zeros of the polynomial 2x square minus 4x plus 5, then find the values of these. Right? In the previous problem, just they had given only ax square plus bx plus c and we found out the values of this. But here particular quadratic polynomial is given. Then how you are going to find out? I'll use the space for solving these two. Before that, we need some information. Do you know what it is? I'll tell you. Look here. First one is 1 by alpha plus 1 by beta. How do you go for writing this? It is to be written by taking LCM. LCM of the denominator, alpha into beta. Then beta plus alpha is nothing but alpha plus beta. Right? Then alpha plus beta. What is alpha plus beta? Will you go for writing minus b by a? No need. Directly you can go for writing here. It is, look here. Here they are given a is 2, b is minus 4 and c is 5. Then alpha plus beta. Alpha plus beta is equal to minus b by a. Right? Minus into, what is b? Minus 4. A is 2. It is equal to minus into minus plus. 2 ones are 2 2s are. Alpha plus beta is 2. Next, alpha into beta is c by a, where c is 5 and a is 2. Alpha beta is 5 by 2. Clear? Here I will go for writing this. It is equal to, where alpha plus beta is 2 and alpha into beta is 5 by 2. It is equal to 2 into, take the reciprocal of the denominator, 2 by 5. So then 2 2s are 4, 4 by 5. Therefore, 1 by alpha plus 1 by beta is equal to 4 by 5. This is the method of finding the value of 1 by alpha plus 1 by beta. There are many methods. Even you can go for solving like this also. Just observe. 1 by alpha plus 1 by beta is equal to alpha beta. Then this is alpha plus beta. What is alpha plus beta? Minus b by a. Alpha beta, c by a. A get cancelled. Minus b by c. Minus into, what is b? B is minus 4. And c is 5. Then it is 4 by 5. See the same answer. Even you can go for another method. How? You can just go for solving it. 2x square minus 4x plus 5. Then when you go for finding the zeros, it will be equal to 0. 5 2s are 10. Then we want minus 4. You just, by solving also you can go for finding. Got it? Now let's move on to second one. Second one is you are going to find out the value of square root of alpha by beta plus square root of beta by alpha. Here I write square root of alpha by beta plus square root of beta by alpha. How do you go for simplifying this? Here in each term there is p by q form, and let us go for applying root to each term. It can be written as root alpha by root beta. This can be written as second term root beta by root alpha. Understood? Now take the LCM. What is the LCM? Square root of alpha into square root of beta. Hope that you have understood. It is square root of alpha into square root of beta is nothing but square root of alpha plus square root of alpha into beta. Now multiply with first term. Beta get cancelled. Root alpha will remain. Root alpha into root alpha. Root alpha whole square. Did you understand? Like this. Root alpha by root beta into LCM is root alpha into root beta. These two get cancelled. Root alpha into root alpha whole square. Next plus. Then multiply second LCM with the second term. Now this time root alpha get cancelled. Root beta will remain. Root beta into root beta whole square. Got it? Now here square and root get cancelled. Square and root get cancelled. This is equal to alpha plus beta, and root alpha into root beta can be written as root alpha beta. Now you tell what is alpha plus beta? It is 2. Square root of alpha into beta, this is 5 by 2. Clear? This can be written as 2 into root 2 by root 5. I have taken the reciprocal of the denominator. This can be rewritten as 2 into root 2 by root 5. As the denominator is an irrational, you can go for rationalizing also. How? Multiply root 5 to the numerator as well as denominator. Now this is equal to 2 into root 2 into root 5, root 10 divided by root 5 into root 5. Root 5 whole square is nothing but 5. This is the value. So here I write. Therefore, root alpha by beta plus root beta by alpha is equal to 2 by 5 root 10. Got it? Yes. You'll go for copying from there to here. After this, again we are moving to another interesting problem. Yes, copy that. Yes. Observe. Third one, in that I have taken the first sub-question. Very interesting. Here they have given alpha and beta are the zeros of the quadratic polynomial x square plus 8x plus 6. Now you just think over it. Is it possible to factorize? No. Then find a polynomial whose zeros are 1 by alpha and 1 by beta. Did you understand? Here they have already given one polynomial whose zeros are alpha and beta. You are going to find out another polynomial. See that. Find a polynomial whose zeros are these. That means you are going to find out new polynomial. For new polynomial, new zeros are given. Got it? Very important. And I am going to put 3 star marks for this. Observe. Here I write. Then, dear students, you all know that how to write a polynomial when its zeros are given, is it not? Here it has been given that you are going to find out the new polynomial when new zeros are 1 by alpha and 1 by beta. Here I am going to write when the new zeros are 1 by alpha and 1 by beta. You also know that how to form a polynomial when zeros are given. How you are going to find out? You will write p of x is equal to x square minus of alpha plus beta, nothing but sum of zeros, right? Sum of zeros into x plus product of zeros. Product of zeros. That means for when new zeros are given, we have to form a new polynomial. To find out the new polynomial, you must know sum of new zeros and product of new zeros. Then what is their sum? Here I write. Sum is new zeros are 1 by alpha and 1 by beta. Here I have less space so that I am continuing here. It is equal to, it can be simplified, alpha into beta. Then it is beta plus alpha. But do you know alpha plus beta and alpha into beta? Unknown. Those are to be found out from you. The given polynomial is x square plus 8x plus 6. Then here we can write alpha plus beta. They are given alpha and beta are the zeros of this. So alpha plus beta is minus b by a. This is equal to minus of where b is 8, a is 1. It is equal to minus 8. Then alpha into beta equal to c by a, where c is 6, a is 1. It is equal to 6. Clear? Now I am going to substitute alpha plus beta and alpha into beta here, where alpha plus beta is minus 8 and alpha into beta is, it is 6. Minus 8 by 6, it is minus 4 by 3, because both are the multiples of 2. 2 3s are 2 4s are. Next, we need product of new zeros. That product can be written as, it is 1 by alpha into 1 by beta. These are the new zeros, their product. This can be written as, here 1 1s are 1, alpha into beta, alpha beta. It is equal to, what is alpha into beta? It is 6. Did you understand? Now, we got new sum, new product. Then we can form new polynomial. So, new quadratic polynomial can be written as p of x equal to x square minus of sum of new zeros into x plus product of new zeros. It is equal to x square minus, what is sum of new zeros? It is minus 4 by 3 into x plus product of new zeros, it is 1 by 6. This is equal to, it is x square, now minus into minus, plus 4 by 3 into x plus 1 by 6. Dear students, observe that. When you observe the denominator terms, you can come to know that here is 3 and here is 6. Then what should be done? So we have to take the LCM of 3 and 6. What is the LCM of 3 and 6? It is 6 only. Okay, 3 and 6. 3 1s are 2s are. Now 3 1s are 3, 3 2s are 6. LCM is 6. Multiply 6 with all the terms. Now look here, 6 into x square, 6x square. Multiply 6 here. 3 1s are 3 2s are. 2 4s are 8, 8x. Multiply 6 to the third term. 6 and 6 gets answer 1. In bracket here I will write, because 6 is multiplied. Understood? Now this is the required polynomial. I can write, therefore, the new polynomial or new quadratic polynomial is 6x square plus 8x plus 1. This is an important type of problem. Once I tell you, listen carefully. Okay, they have given alpha and beta, they are the zeros of given polynomial. Next, they have given new zeros. Hence, we have to find out new polynomial. That is, using the first polynomial, we have to form second polynomial. So, in first polynomial, we have alpha plus beta and alpha into beta because they are the zeros. Clear? You will have to find out this one. Next, you have to take new zeros. When new zeros are, that is given zeros, 1 by alpha and 1 by beta, you find out new sum and new product. You will get minus 4 by 3 as the sum, 1 by 6 as the product. Then we have to find out new quadratic polynomial. Again, general form should be written. Earlier we used to write x square minus of alpha plus beta into x plus alpha beta. But as we are going to form new polynomial, hence I have written sum of new zeros and sum of product of new zeros. They are to be substituted. At last we get the new polynomial. So first one is x square plus 8x plus 6 and second one it is 6x square plus 8x plus 1. I hope that you have understood this. Now you are going to copy from there to here. Dear students, you have been observing just only for the sake of highlighting about forming the new polynomial. Hence I have used the word new zeros, new polynomial. Yes, copy from there to here. Now I have taken one more problem which is of same type. Let's go for solving. You can just recall the steps with me. First we shall go through the given statement. See that here also, if alpha and beta are the zeros of 2x square minus 5x plus 7, even this is also a quadratic polynomial. Find a new polynomial when new zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. Okay, now dear students, I have already told you, first you have to find out sum and product of the given polynomial. Given polynomial is x square minus 5x plus 7. Then sum of zeros, they are given alpha and beta are the zeros. Hence I can write alpha plus beta. This is minus b by a. Minus of, what is b? B is minus 5. A is 1. Now minus into minus plus 5. 5 by 1 is 5. This is alpha plus beta. Next, let us go for finding product of given zeros. Alpha into beta is c by a, where c is 7 and a is 1. 7 by 1 is just 7 only. This is about the given zeros with the given polynomial. Now we are going to form new polynomial when new zeros are given. Could you tell what are the new zeros? Yes, you are right. They are 2 alpha plus 3 beta is 1 0 and another new zero is 3 alpha plus 2 beta. Here I am going to write when the new zeros are what are those? 2 alpha plus 3 beta and 3 alpha plus 2 beta. I am going to highlight that by underlining them. Look here. Here new zeros are there. To form new polynomial, we need new sum and new product. Here I am going to write new sum, that is nothing but sum of new zeros. Sum of new zeros, it is 2 alpha plus 3 beta plus 3 alpha plus 2 beta. This is equal to, look here 2 alpha, here 3 alpha. 2 alpha, 3 alpha, 5 alpha plus 3 beta plus 2 beta. It is 5 beta. Hope that you have understood. It is equal to 5 into, go for, here 5 is common factor, hence we can write 5 into alpha plus beta. Understood? It is equal to 5 into, we know the value of alpha plus beta. It is 5. 5 5s are 25. It is new sum, that is sum of new zeros. Next, we need product of new zeros. New zeros are 2 alpha plus 3 beta into 3 alpha plus 2 beta. This is equal to here, from here I am writing. Now multiply 2 alpha with both the terms. 2 alpha into 3 alpha, 2 3s are 6. Alpha into alpha, alpha square. 2 alpha into 2 beta, 2 2s are 4. Alpha into beta, alpha beta. Now multiply 3 beta with both the terms. 3 3s are 9. Alpha into beta, alpha beta, plus 3 2s are 6. Beta into beta, beta square. It is equal to, now observe it, 6 alpha square plus 6 beta square. I am writing the square terms one side. 6 into alpha square plus beta square. Hope that you have understood. Now 4 alpha beta plus 9 alpha beta. How much it is? It is 13 alpha beta. Next, this is equal to, I am continuing here regarding the product. 6 into, we do not know what is alpha square plus beta square, but we know only alpha beta and alpha plus beta. Hence, let us write alpha plus beta, alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta. In the very first problem only we have already come across the value of alpha square plus beta square plus 13 alpha beta. Hope that you have understood. This is equal to, now multiply 6 with both the terms. It can be written as 6 into alpha plus beta whole square. Multiply 6 with second term. 6 2s are 12 alpha beta plus 13 alpha beta. Clear? This is equal to 6 into, what is alpha plus beta? It is 5. 5 whole square minus 12 alpha beta plus 13 alpha beta. It is 1 alpha beta. So greater number is 13, its sign is plus. So 1 alpha beta, 1 alpha beta is nothing but 7. It is equal to, what is 5 square? 25. 25 6 are 150 plus 7. It is 157. Hope that you have understood. Next, it is, we got new sum and new product. You can go for writing new quadratic polynomial. What is that new quadratic polynomial? P of x is equal to x square minus half sum of new zeros. Sum of new zeros into x plus product of new zeros. It is equal to x square minus, what is the sum? Sum is 25 into x plus product, it is 157. Now this is the required polynomial. Therefore, I will write, therefore the polynomial, the quadratic polynomial is x square minus 25x plus 157. Yeah. Please go for copying from there to here. Dear students, hope that you have written up to here. Observe. Here actual polynomial is, this is x square minus 5x plus 7. You make it correct. Here 2, you had written 2. Remove that, x square minus 5x plus 7. Same thing has been written here. Here a is 1, b is minus 5 and c is 7. And it has been written according to that. Observe. First, using the given polynomial, we have found out sum of the zeros and product of zeros. Then, next we have taken new zeros. Taking new zeros, we have found out new sum and new product. After finding new sum and new product, then we have found out the new polynomial. That new polynomial is, it is x square minus 25x plus 157. Okay. Dear students, still we have some more important problems are there. We can go for solving them in the next class. And before concluding the class, again I have been reminding you, today's class is very important. Whatever we have covered the syllabus, please do practice them today itself. Got it? Actually today we had to take the science, but instead I continued mathematics. It was much needed. It was much needed as it was related to yesterday's concept. Okay. With this, let us stop the class. Thank you.